So, Avantika, today we will discuss this remaining topic in vectors, vector product, vector product. I'll just spend 2 minutes revising what we have done till now. So, this was a part one. In part one, we started with the introduction of 3D plane. We did the IGK clap. We understood caps. We understood what are unit vectors. We understood what is how does a point xyz look like in space. Then we understood the concept of resolution of vectors. So this is what we did in part one. So by the time we finished part one, we had a fair amount of idea what is vectors and what are the basic operations in vectors. This is what we did in part two of vectors. Basically, we understood how to add, subtract vectors. We understood the triangle, parallelogram, polygon laws. We understood that multiplication in vectors can be of two types: scalar multiplication, vector multiplication. We understood the concept of dot product. Then we did a numerical for calculating the work also. Any doubt in the lecture 1 or lecture 2?
No,
This is
sir.
one thing. Yeah. Now, as a homework, see, I have detailed lecture on cross product, the topic that we'll be doing today. So there are two lectures that you'll have to see. One is a around 50 minutes lecture. A lot of short numericals are there. And this one again is for around an hour. And again, lot of numericals are there. Mr. Vantika, any doubt?
No, sir.
I'll send you the lecture links. This would be your homework till Tuesday. These two videos of cross product. I'll give you a brief introduction of how the cross product works like. It won't take more than 10-15 minutes. The concept is pretty simple. The only thing that you'll need to do is you'll have to practice. Would you be able to do that? And practice just from the two lectures that I'll be sending you. Am I clear?
Yes, sir.
Okay. So one of the concept is, can you see this figure of
Yes, sir.
see one thing? This is a right hand, and another thing that if I have to find the product of A cross B, it is called A cross B. A cross B. This is how it is written. The dot product we wrote it like this: A dot B. This is what is called a scalar product. This is what is called a vector product. Then, just to add to confusion, this is also called dot product. Why? Because there is a dot here. And this vector product is also called a cross product. Why? Because there is a cross here. Avantika, are we clear till here?
Yes, sir.
Now, if I take a very simple example of a dot product, very simply, if I have to find dot product of, let us say, 2i plus 3j minus k dot I minus j plus 3k. So if you remember, all that we need to do is multiply these two, multiply these two, multiply these two. That is it. And I will find the answer as 2 minus 3 minus 3. Am I right, Avantika?
Yes, sir.
And the basic answer that I will get is I will get minus 6 plus 2 minus 4 as the answer. Ms. Avantika, any doubt till here?
No, sir.
Okay. So in scalar product, basically, I get just one number. Am I clear?
Yes, sir.
So in scalar product, I get just one number. That is it. But in vector product, what happens is that I get another vector. Let us try to understand that. So let us assume I want to find a cross product of this vector and this vector. Now, how I write this is there is something called a determinant, and that is what I was trying to tell you, that you will have to watch the lectures and try to solve the questions which are being discussed. So the technique is very simple. Simplification, let me write the I first. So I, then 1 into 1 minus 1 into minus 1 is plus 1, and I write minus 1 because I am going up. And then when I have to write j, I would write a minus j here. One thing, am I clear?
Okay, it's like a set rule to be minus j.
Yes, it is a set rule.
Okay. Okay.
So minus j, so the first is positive, second one is negative, and then it is positive. Yeah. So it is by
Yeah.
default that the negative will come. Are we clear? Like it is a
Yeah.
default that when we are multiplying up, it is negative. So by default, this j is negative. Am I clear?
Okay. Yeah.
Okay. So let us go to the j. So when I'm dealing with j, what I need to do is, let me remove this and use another color. Yeah. So this is minus j. So j, 3 into 1, 3, and 2 into minus 1 is minus 2, but I am going up, so it is plus 2. And finally, plus k, again, 3 into minus 1 is minus 3, and 2 into 1 is 2. One thing, am I clear? Now it is making
Yeah,
sense.
sir.
So I into 0 minus j into 5 plus k into minus 1. Or this would be minus 5j minus k. One thing, am I clear?
Yeah, sir.
Now let us do this question. Question number 13th. Determine the vector product of these two. So ijk, I've written ijk. The first vector first, 2, 3, minus 1, 2, 3, minus 1, 1, 2, minus 3, 1, 2, minus 3. So the format is okay. Now let me start doing the question. Okay. So I will write this as I. I is positive. See, this is positive, this is negative, this is positive. So I minus 9 plus 2 minus j. 2 into minus 3 minus 6. And 1 into minus 1 is minus 1, but I'll have to take up plus 1 plus k plus k. So 2 into minus 3 minus 6. 1 into minus 1 is minus 1, but I'll have to change the sign. So it is plus 1. So the answer would be minus 7i plus 5j minus 5k. Mr. Mathika, am I clear?
Yeah.
Now, this is what I was trying to tell you in the beginning, that this is how the scalar and the vector product differ from each other. Though it is not asked in the question, though it is not asked in the exams, but I'll just, you know, try to tell you the difference between scalar and vector product. So scalar product is equal to the product of magnitude of the vector and the cosine of the angle. If you remember, it was a dot b. This was equal to a b cos theta. And if you see, if you observe, This would be a number, this would be a number, this would be a number. So when we take a dot product, it is always just a number, only a number. Have you understood, Avantika?
Yes, sir.
And you know what we have calculated now. So if I write the definition of a vector product, this is how it looks like. This is how it looks like. That A cross B, it is written like this: magnitude of A, magnitude of B, sine of the angle between them. Are you clear till here?
Yes, sir.
And then there is a unit vector. This is called a unit vector whose direction is given by the thumb rule. Which thumb rule? This thumb rule. Have you understood? So
Yes, sir.
this direction, A cross B, this would be the direction of the unit vector. Am I clear?
Yeah.
So this would be equal to A, B cos theta. That is it. No direction, just a number. And this would be equal to A, B sine theta. This would be a number, but then it will be multiplied by a unit vector. The direction of the unit vector would be given by this thumb rule. Am I clear, Avantika?
Yes, sir.
And that is why if you see the answer that we get in a vector product is a vector, is again a vector. Am I clear?
Yeah.
So scalar has no direction. Of course, it has no direction. And in vector, direction is perpendicular to the product in the sense of the advanced screw. This is what we had just discussed now. Am I clear till here?
Yes, sir.
Now, another thing that you'll have to see is, I'll cover the easier topics first. I'm skipping this for now, just for 5 minutes. So it is 0 if the two vectors are perpendicular to each other. Why? Because there is in dot product, there is a cos theta. But in vector product, there is a sine theta. So that is why if the two vectors are perpendicular to each other, this is 90 and cos 90 is 0. That is why it becomes a 0. Am I clear, Avantika?
Yeah.
But if in a vector product, the theta is 0. How is theta 0? When the two vectors are parallel. Then sine theta is 0. And then the cross product is 0. Am I clear?
Yes, sir.
This is easy to understand. So for example, I am taking a dot product of a vector by itself. So this will be equal to magnitude of two vectors cos 0. That is it. Cos 0 is 1. That is why they are saying that the self dot product of a vector is equal to the square of the magnitude. Why? Because this would be the final answer. Am I clear?
Yes, sir.
But here, because the sine theta will become 0, that is why they are saying that the self product of a vector is 0 vector. Am I clear?
Yes, sir.
Again, parallel, why it is maximum? Because cos theta is maximum when theta is 0, because it takes a maximum value of 1. If you remember trigonometry, the maximum value of cos used to be at 0. But here, it is only when the vectors are perpendicular to each other, because sine 90 is 1, that the magnitude would be maximum. Am I clear, Avantika?
Yeah.
I'm just comparing the dot and vector product. Usually this is not asked in the exams, but just for the heck of it, even if you are able to say write 2 or 3 differences, it should be good. So this commutative, non-commutative, basically what it means is, that, for example, 4 into 5 in our basic multiplication, class 6 multiplication, 4 into 5 was equal to 5 into 4. This is called the commutative law. Have you understood?
Yeah.
So what they are saying is A dot B would be equal to B dot A. For dot product, it is fine. But if you are trying to take a vector product, this won't be equal to B cross A. Am I clear, Avantika?
Yeah.
So that is what difference of vector product is, and few other properties of vector product if you want to see. So this is what they are saying, that the cross product of two is anti-commutative. So A cross B is actually equal to minus B cross A. Am I clear?
Yeah.
Cross product obeys the distributive law. So if there is a cross B plus C, it can be written as A cross B into plus A cross C. Am I clear?
Yes.
It is associative also. So this you won't be using it much. But one thing that we can discuss is, if you remember, one thing that we can discuss is, because that might be used in few numericals. If I have unit vectors, this would become a bit interesting. So if there is a dot product of two same unit vectors, so this would be equal to magnitude of I cos of 0. I'm taking a dot product. If you see, I'm taking a dot product. So this is 1, this is 1, this is 1. So answer is 1. Am I clear? One thing.
Yeah.
But if I'm doing I cross I, then the interesting thing happens that I, but then here is a sine 0, and 0 is, sine 0 is 0, therefore this becomes 0. Do you see that?
Yes.
So I dot j, this is discussed in detail in the lectures that I'll be sending you, but I just wanted you to have a glimpse. So I dot j, because there will be I dot j, there is a 90-degree angle between them, so this would be 0. Am I clear?
Yes.
But then if you take I cross j, this is I, this is j, there is a 90-degree angle. Sine 90 is 1. But the unit vector, the direction of the unit vector, if you apply the right hand thumb rule, the direction would be given by this k vector. That is why I cross j is k vector. Is Avantika, is it making sense or not?
Yeah.
So again, what I'll suggest is, you'll have got a glimpse of what vector products are all about in these 15-20 minutes. So what I'll suggest is, because Monday there's a very high chance we won't be having a class. So spend some time on these two lectures.
Yes.
This is introduction to cross product. Introduction to cross product, and here vector product theory and numericals. These two lectures, spend some time. 1 hour
Yes.
plus around 2 hours. Basically, 2 hours you'll have to spend. Is it okay?
Yeah.
So most probably we'll meet on Tuesday. If we are meeting on Monday, I'll let you know. Yeah.
Yes. Yeah.
Yeah. I'm ending the meeting.
Yes.